Alrighty guys, we are going to talk about another form of a quadratic today. So today we're going to talk about standard form, and we're going to graph with that one on 106 and 107. That's funny, most people start with standard form because it's like standard. You should do that one first. But the reason that I don't is because vertex form is just so easy. Like, I love to graph so much, and I want you guys to love to graph. In vertex form, like, literally all the numbers are there for you. You just have to find them and put them in the right spots. Sadly, standard form is not as helpful, and that's why I feel like I kind of want to save it so that you guys maybe like graphing a little bit, and so when we have to do a little bit more work for it, it's not quite as bad. Alrighty, so turning to 106 and 107. Just like I did for vertex form, we're going to start on 107 here and do some of this stuff, and then in a separate video, I'm going to do more examples on 106. Okay, so when we are in standard form of a quadratic, sort of the important thing to notice so that I know that I'm in standard form and not vertex form is that standard form will always have an x squared and an x. So if it has both an x squared and an x, I know that I'm in standard form. Versus like vertex form only has one x and it's got these parentheses. So like there's only one x here. There are kind of two x's for standard form, an x squared and an x. So that's kind of how I can tell the difference. And if you notice, when we're looking at standard form, this ax squared plus bx plus c, that might look familiar from last chapter when we were talking about factoring, which we're going to get to that. Now, like I said, standard form is a little bit of a bummer because there's not as much obvious information when I'm just looking at standard form. I have to dig a little deeper for it and do a little bit of math to get it. However, like with vertex form, my a value out front here on top of your a squared is still like it was in vertex form. It's still sort of your slope that I can do once, and I have to remember that it's rise over 1. Okay? The b value kind of doesn't tell me too much about what the graph is doing, so we kind of skip that one for now. The c value, though, that's kind of a helpful number. Whatever c is my y-intercept. So it's not the most helpful point, but it is still a point on my graph. So like 0, c is my y-intercept. Like if you remember about vertex form, it was kind of hard to find our y-intercept. Like we had to sort of do all this math. With standard form, finding your y-intercept, super easy. I don't have to do anything. It should just be sitting at the end there. I just take it. The problem is the most important point of a parabola is the vertex. And unfortunately, it's sort of buried inside of your problem here. So we have to get it out by doing a little equation. So to get my vertex when I'm in standard form, we have to do a little formula to find the x value. And we're going to do negative b divided by 2a. So like b is that middle number, a is that front number. I plug it into this little formula and I get a number out, like maybe I get 2. Then I take that 2 and I plug it in for x to get the y value. So plug that in to the equation. Okay, so kind of a bummer. It's not as easy as vertex form was. So like my a value there gets me slope. C value is kind of helpful, but the vertex kind of sucks. Okay. Alrighty, so jumping right down to it, let's talk about our steps for graphing success. If I want to graph something that is in standard form, I still, like vertex form, need to find and plot the vertex first. However, it's just a little bit trickier because we have to do that negative b over 2a and then plug it in to get the y value. So we have to do some math first to get our vertex because that is our most important point. Once I have it, then I can use a as slope like we were doing last time for vertex only once. And we have to do rise over 1. And then, actually, I can get a really nice looking graph on this one because I already did the hard stuff, and I can find the y-intercept really easily. It's just at 0, c. Okay, so kind of have to do a little math problem, but then the rest is simple. Okay, so if we look at this quadratic right here in standard form, and I can tell it's standard form because I have an x squared and an x. The first thing that I need to do is find that vertex. So we have to do our little negative b over 2a and then plug it in. So looking at this graph here, the b value is negative 8. So that goes on top of my fraction, divided by 2 times the a value, which is 2. I wrote this way too big. Oops. So when I do that, negative negative makes it a positive. 2 times 2 is 4, and 8 divided by 4 is 2. So I can see that the x value of my vertex is 2, which is also low-key where your axis of symmetry is, so that's nice. And then to find the y value, I'm going to have to plug that 2 in, both spots, for the x, which that's going to take a little room. So I'm going to do that off to the side here. So I take this 2, and then in place of x, I need to now put this 2 squared minus 8 times 2, and then plus 6. My gosh, we had to really squeeze her in. Then I need to follow good order of operations. So I need to do my exponent first, and 2 squared is 4. Okay, then I can do multiplication. So I have multiplication right here, and 2 times 4 is 8. I also have multiplication right here, and 8 times 2 is 16. Now I just have addition and subtraction, so I'm going to go right in order, and like 8 minus 16 is negative 8, plus 6 is negative 2. So we had to do all that like side math to get that the y value of my vertex is negative 2. Ugh, I know we don't love it. But now the rest is easy. So the second thing I want to look for is my a value, which is just the number up front. So I can use that as slope. And thirdly, finding that y-intercept is super easy. It's just going to be 0, c, which my c value is 6. Okay, so hard part out of the way, then we can graph easily. So first we want to plot that vertex, which is at 2, negative 2. This is also where my line of symmetry is, which can be super helpful to draw. From there, I can use a as slope once, so I can go up 2 over 1. But it does help me to get another point because I can flip it over my axis of symmetry and put it on the other side. And then lastly, I can find my y-intercept super easily. It was at 0, 6. And again, that actually gives me another point because I can flip it and put it on the other side of my axis of symmetry. Real cute, skinny little graph, pointing up, has a minimum. We love that. Let's try a couple more. Now this one has only 2 on the inside here because these ones are a little bit more time consuming. But guys, if you're still feeling a little bit struggly with these, I'll have that second video where I'm going to do more examples on page 106. Okay, so looking at this one here, I can tell that it's in standard form because I have an x squared and an x. That first step is to find my vertex by using my little baby formula, negative b over 2a, and then plugging it in. Now, a lot of people ask where that little baby formula comes from, and it's real interesting, but you'll have to wait for Algebra 2 to figure it out. Just trust me for now that it works. Okay, so my b value is always on x. It's like that middle number, so we'll have -7 over 2 times my a value, which is 1. And so if I simplify this, the top's going to be -7, the bottom's going to be 2. Now, sadly, this does not divide evenly, and I think, shocker, I think I'm actually going to change it to a decimal. And the reason being is because I have to graph it, and I want to know exactly where this is. So when I divide this out and get a decimal, we are at -3.5. Okay, so this is the x value of my vertex. Now to go find the y value, I have to take this x value and put it in for both of these x's in my equation. So we will do, in place of this x, -3.5 squared, then plus 7 times -3.5, and then plus 12. Now, I'll tell you right now, y'all, I'm pretty good at squaring fractions, but I'm not super good at squaring decimals, so I'm totally going to use my calculator here and square this number. So if I do -3.5 times -3.5, I know my answer is positive, so I'm not even going to worry about the negative. I'm just doing 3.5 times 3.5. So 12.25. Now, also right here, I'm not super good at multiplying decimals, so I'll just do that as well. But I'm not going to mess with the negative because I know that a positive times a negative is a negative. So I'm just going to do 7 times 3.5 for 24.5 plus 12. And now that I've taken care of the exponents and the multiplication, because they didn't really affect one another, now I can just combine all my like terms. And so 12.25 minus 24.5 is -12.25. And I knew that so fast because this is just double as much as that. So if I subtract a doubled amount, then I have exactly the same amount left, if that makes sense. And then -12.25 plus 12, the 12s are just going to come off and you're left with -0.25. What a yucky mess. So -0.25 is the y value of my vertex. I might want to put a line down here so we keep these ones separate. This is kind of why we could only do 2 on this one. A lot of work. But the rest of it's easy. So secondly, I want to find that slope, which is my a value, which is the front number, which if I don't see it, it's 1. And then thirdly, I can find that y-intercept. It's always 0, whatever the last number is, not on an x, so 12, which I'm really not going to be able to fit on this little baby graph right here, but that's okay. Let's go plot our vertex. So we'll go to -3.5, and then comma -0.25, which is super small. It's not even 1, and it's not even half either. So I really just want to go right below that line. And then that is also where my axis of symmetry is, which can be helpful because then I can flip points over and get more points. So from here, I can get another point by doing my slope of going up 1. Now, the thing is, I'm like right below the line. So when I go up 1, I'm going to be right below the next line. Oop, and then I got to go over 1. Oops. Which if I'm going over 1, halfway in between, I'm going to be halfway in between the next one. Man, this parabola is kind of a hot mess. And I definitely can't fit my y-intercept on here because this only goes up to 7, but like it'd be there and then I could flip it over, put it on the other side. So I'm just going to kind of sketch out what I have right here. Like this one's reaching for 12. And then there you go. You got a cute little parabola that has a minimum value, is pointing up has a domain of all real numbers and a range of y is greater than or equal to negative 0.25. Ugh. Okay, let's just move on to the next one. Maybe it'll be better. Okay, first thing we want to find is that vertex. We find that vertex by doing negative b over 2a and then plugging her in. So let's go do some side math over here and get that done. So if I want to find the x value of the vertex, I want to do negative b, so 2, over 2 times a, which is actually negative 1. So when I simplify here, I'm going to have negative 2 on top and also negative 2 on bottom, which divides out so nicely. Thank goodness, that's 1. Then I want to go find the y value by plugging our 1 in for x and then simplifying all of our math out. So we have this negative out front of a 1 squared. And we have plus 2 times 1 plus 3. So we want to do our exponent first, and 1 squared is 1. And then there's a negative. So it ends up actually being negative 1. Now squaring always produces a positive number, but then it's sort of like low-key. There's a negative 1 right here that's being multiplied to it. So that's why it changes to a negative 1. Right here I can multiply, it's not going to affect anything. So 2 times 1 is 2, and then plus 3. And then since we're just adding and subtracting all this stuff, we can just do it. So negative 1 plus 2 is 1, plus 3 is 4. So the y value of my vertex is 4. Oh my goodness, love it when it's so nice and not a yucky decimal. Second step, we want to find that slope, because that can help me get some good points on my graph. And this slope on x squared is negative 1, which, if we remember from the vertex form, means that this graph is going to be pointing down. And then the last thing that we can do that is super easy is find that y-intercept. It's at 0, comma, whatever that c value is, the number not on x, so 3. All right, I think we can make a real good looking graph here. So we're going to plot that vertex at 1, comma 4. We're going to maybe draw in our axis of symmetry because that can be helpful to see. Because when I go and do my slope now of down 1 over 1, I can then flip that over, put it on the other side. Dang it, that's my y-intercept. I was hoping I could get another point. Yeah, it's fine. We can see this little cutie right now. This parabola is so pointing down, which means that it has a maximum value, because the top of the graph is like the tippy top, so max value. And guys, I know this can be really frustrating because it seems like so many steps, but always have your notes out and follow them step by step so that you don't get lost. This thing on the outside right here tells us exactly what we got to do. We got to find and plot our vertex. We do have to do some math to get that. Then I use my slope. Then I do my y-intercept. I'll see you on the next one.